Hello and welcome to the first video I'm going to make on Unit 66, which is Theory of Flight. This is heading towards the completion of Assignment 3. Please bear with us. I am currently talking to a tiny little camera and I'm not really used to this, so it's just to get the information across. It's not meant to be a serious YouTube video where I get loads of likes and things like that, and people, like what YouTubers do. This is just to get the information across to people that may have missed the lesson, okay, and basically go through. Some of you have had this lesson already. It's when we came out of the hangar to look at the jet polished aircraft, yeah, and we're going to look at the ailerons, we're going to look at the rudder, and we're going to look at the elevator, okay. So, first thing is the basics of the flight controls on the airplane. The ailerons, for the criteria that we're going to look at, you basically what we're after, what the BTEC criteria is after, it's after you knowing what you're talking about with basic primary flying controls. So the primary flying controls on that part of the task, stick to the primary flying controls. Don't start talking about anything else. Don't start talking about trim tabs or flaps, right? Okay, right, these are the flaps, these are the ailerons, totally separate things, right? Stick to the Billy basic stuff you were taught and make sure that you get it right first time, okay, and don't get things the wrong way around. So the first thing is the basic stuff, is the ailerons control roll, okay. So the aileron, if this aileron goes down, it's going to make the aircraft roll to the right. Okay, if this aileron is up, it's going to make the aircraft roll to the left. The other aileron will be doing something completely opposite, and they always work in opposite to each other. So if we just look under the jet there, there you go, the other aileron's down, right. The elevators control pitch, okay. So the elevators, if the elevator goes up like that, right, it's going to make the aircraft pitch up over. If it goes down, it's going to make the aircraft pitch down. And the rudder, if you want to control the rudder to the right, is going to make the aircraft yaw to the right, and the opposite way, it'll make it yaw to the left. Now, that's the basic stuff. So the basics are, if you look at a wider view of the aircraft, is where are they located and basically what do they do? That is only 50% of the answer. What we now need to do is once you've got that across and you've put in your assignment that you know what you're talking about, what we now need to do is we need to go in depth. What we're really interested in is how is the airflow modified over the wing to affect these different control surfaces. How do they actually make the aircraft roll, pitch and yaw? You don't need to do this 3 times. One really good explanation of how the aileron works, or how the elevator works, or how the rudder works, whichever one floats your boat, right, whichever one you want to do, just do it in that really good detail with some diagrams. So if you've drawn a diagram to say where the aileron, rudder and elevators are, yeah, that's okay. But I also need at least one highly detailed diagram, right, with all labelled up with how the thing works, how it modifies the airflow. And it does that in 3 different ways, okay? So remember, there's 3 different ways that it works. Now, you will see other people talking about downwash and things like that. I'm not going to talk about downwash because basically that's, well, I'll talk about that in a minute, okay? Right, so the first thing is use correct terminology. Use the correct terminology, okay? So I've talked about, you've already learned in topic 1 about angle of attack. You've already learned about the Bernoulli effect, right? You've already learned how lift is created by a combination of Bernoulli and Newton's third law of motion, right? And all of this is going to come to the fore when we talk about how a control surface works. So the first method, or the first kind of effect that a control surface has, if the control surface is pointed down over, right? One of the terminology that you learned in topic 1 was camber, the curve of the wing, okay? So as you can see here, this wing is now a lot more cambered. It is more curved, it is more cambered. This is going to accelerate the flow over the top surface of the wing slightly more than it was if it was just a straight camber like that. So you're going to introduce more of a curve into the profile of the wing, just at the wing tip, just where the aileron is located, which is going to slightly speed up the airflow over the top of the wing a little bit more. It's going to create a bit more lift on this wing. Yeah. One of the 5 factors affecting lift. Remember from topic 1, the 5 factors affecting lift, or maybe topic 2, I can't remember. 5 factors affecting lift are density, angle of attack, shape of the aerofoil, size of the aerofoil, and velocity. Yeah? So one of the factors affecting the lift on a wing is its camber or its shape. Make it more curved, make it more cambered, you're going to get more lift. Okay. Other ways to affect lift. One of those factors was angle of attack. So if we look at, again we're looking at terminology, we're looking at chord line. The chord line always goes from the leading edge of the wing, a straight line to the trailing edge of the wing. So the chord line always goes from that point there directly to that point there. So as you can see, this chord line would actually follow pretty much the bottom surface of the wing, really, just above that bottom curve of the wing. So you've got the bump on the top, which is creating the lift according to Bernoulli and Venturi's theorems, right? And you've also got the bottom surface of the wing. Now, if we lift this wing up and give it an angle of attack, which I can do with the camera now, yeah, so it's got an angle of attack, we know from our previous studies that the air is going to come, it's going to collide with the bottom of the wing, right? And according to Newton's third law, yeah, to every action there's an equal and opposite reaction. So the force of the air hitting the bottom of the wing is going to try and push the wing out of the way. Okay, and if the wing's at that angle, it's going to push the wing up slightly. So if we increase the angle of attack of the wing, we know we get more lift according to up to the critical angle, which is 15 degrees. Don't worry about that for now. For control surfaces, that's more lift. Can you now see how we need to know lift exactly? We need to know how lift works in order to discuss control surfaces. It's like I said in the lessons before, you're unlocking different language as you go along. You're always unlocking extra bits of knowledge that you need to use for the next bit. When we come to do high-speed flight in topic 4, we're going to put all of this together in one big, massive kind of mixing bowl. And we're going to basically, you need to know everything in topic 1, 2, and 3 to unlock topic 4. It's like a computer game. You can't do the boss level at the end until you've beaten all the mini bosses on the way along. Right, so what we've got here, we've got your angle of attack, you've got your chord line, goes from your leading edge to your trailing edge. Okay, always from your leading edge to your trailing edge. If we now adjust the chord line, we put that down, our trailing edge is now here. So that chord line has changed. Okay, and the oncoming airflow, the relative airflow, some American websites sometimes call it the relative wind, and I don't like that. Yeah, but that's just me. The relative airflow, okay, is coming from this direction. Now, because the chord line's changed, the angle of attack is always measured from the relative airflow to the chord line. So now our angle of attack has increased. Now you can say it's only increased over this surface of the wing where the control surface is. So you can say in your assignments that the effective angle of attack has increased. Okay, control surface goes down, increases the effective angle of attack. Okay, what else happens? I mentioned previously, Newton's third law of motion comes along the bottom, the air hits the bottom of it, it's going to hit into that, it's going to be deflected down over, mainly by the bottom surface of the wing. Okay, if you think about it, there are some websites out there, there are some, lots of really, really good, I mean, NASA probably agrees with this, yeah, it does happen. The air is going to be deflected down from the top surface, and it's going to come down in this sort of motion here, and that's going to create a little bit of, you know, to every action there's an equal or opposite reaction. But lots more prevalent is the fact that it's hitting the bottom surface of the wing. This is a piece of metal, it's smacking that, it's going down over, it's deflecting it down. Just like if you stick your hand out of the car window, yeah, if you stick your hand at that angle out of the car window, it's going to be pushed back over, isn't it? Yeah, because of the I have to kind of move the camera here. Okay, because of the pushing on the bottom of there, it's going to push out of the way. Okay, so there are three methods that's happening, right? We've got the more camber. More camber is going to create more lift. You've also got the altering of the chord line by moving the trailing edge down. That's going to increase the effective angle of attack, which is going to create more lift. And we've also got the third one, which is Newton's third law, something sticking down there, smacking into it, it's trying to push it out of the way, which is actually pushing it over. Okay, sorry that this isn't scripted, this is totally off the cuff, and I'm making this at kind of 6:30 at night, just to kind of get the message across to people that are going to have to say assessments shortly. Okay, so it's not very professional, I do apologise. Okay, so what else can we say about this? If it's happening here, yeah, we're going to create more lift on this section of the wing. It's going to lift this wing up. Okay, What's going to happen to the rest of the control surfaces? Exactly the same thing. Don't worry about this bit for now. Right, this is the balance horn. Okay, don't worry about that. Don't worry about the trim tabs for now. This is just one task. The elevators, okay, the elevators move up and down together. Yeah. Now, again, don't go into stabilators and tailor-ons yet. They are advanced flying controls. Stick to the basic ones for this task. Yeah. If you want all the bonus points there, the merits and distinction points later on, you can talk to your heart's content about that. I want you to do that. I want you to do some really good research and add them in. Okay. Right. So if the elevator goes up, what's going to happen is, it's now, we know that from our previous studies that the tail, the horizontal stabilizer, is an upside down aerofoil. It's mainly curved on the bottom to create downforce or lift in the downwards direction to balance out the whole aircraft. We've done that in topic 2. Okay. But if we then created this shape, as you can see, it's still an upside down airfoil. We're making it a more pronounced, more cambered upside down airfoil, putting a lot more curve on there. We've got some Newton's third law going on there. Yeah, and we've also got a change, as you see, from the leading edge to the trailing edge of the angle of attack in the downwards direction. It's going to produce a lot more lift down over in this configuration. That's going to push the tail down, yeah, which is going to bring the wing up a little bit. The air is going to hit the bottom of the wing, and it's going to make the aircraft climb. So when the elevator goes up, tail goes down, but the whole aircraft pitches up and starts to climb. When it goes down, the opposite happens. You notice on this aircraft, the elevator goes up a fair way, but it doesn't go down quite as much. We'll talk about that in later videos. Okay. But as you can see, now we're going to create some lift. We're making it curve this way. The lift's going to go up over, which is going to raise the tail, and the nose is going to go down. Looking at the rudder, I'm going to leave the rudder in that position for now. Walk around the front of the airplane. As you can see from the top there, I don't know if you can see that right. The rudder's curved in one position. Whichever way the rudder's curved, so the rudder's now curved that way. Yeah, there's the curve. The lift is going to go this way. That's going to pull the tail around in this direction, and then it's going to pivot the nose around in the opposite direction. So whichever way the rudder pivots, if the rudder's going that way, it's going to create lift in that direction, and the nose is going to yaw round to this direction here. Okay, I was pointing the camera the wrong way there, sorry. Okay, that's pretty much everything I'm going to teach you about, the basic primary flying controls. Okay, so if you get a task on that on the assessment, that's what you need to think about. Stick to the basics. I would much prefer you to do a detailed diagram and description of how one of them works with all of the things I've just talked about, rather than going into other parts of it. This is not part of the task just yet. Okay, so stick with the basic flying controls, get them the right way around. Okay, the worst thing is to get a referral where you've done a really good diagram and description how the lift's modified, how the airflow is modified, and how the airflow controls the aircraft, and then turn around and say, oh well, if the left aileron goes down, yeah, then the nose goes up. Yeah, so remember, ailerons for roll, rudders for yaw, elevators for pitch, left aileron down, more lift on this wing, the aircraft's going to roll to the right. Okay, right, thanks for watching. Hopefully I'll get a bit more practice at this, and we'll do some more later on. Definitely want a close up of me. I'll see you later.